Hello everyone, welcome to the Ethereum Cat Herders EIP special community call. For those who aren't familiar with the group, Ethereum Cat Herders is a decentralized project management group for Ethereum community. I'm Pooja Ranjan, the herder-in-chief of Ethereum Cat Herders, and today's host. We are going to talk about EIP-3074 AUTH and AUTHCALL opcodes. So we have been joined by co-authors Sam Wilson, Ansgar D, Matt Gannett, with a wide variety of people from dApp developers, infrastructure providers, and researcher community. EIP-3074 is a standard track core EIP proposed in October 2020 and currently in review status. Currently on independent developers testnet, this is also in the process of getting an audit done with the help of Ethereum Foundation. So I suppose with the cryptocurrency, people are generally cautious about the security. So audit was needed in this case. The goal of this community call is to demonstrate what this EIP has to offer to the Ethereum developers and users and get answers to potential concerns. So without further ado, let me pass it over to the co-authors.
Thanks, Pooja. Now, so let me share my screen and we can just talk about 3074. So thanks for coming to the second community call. I see a lot of people who joined us for the first community call a few weeks ago. So I'm going to keep the review of the EIP pretty short, but we'll have some time to ask questions and discuss things if we want to go into more depth there. So last time I said the main motivation for 3074 was sponsored transactions. And, another motivation that we had back then was also to have better user experience for EOAs. And something that we have changed since we last talked is that before, when we spoke in the last community call, we were not allowing self-sponsoring. So that would mean that a EOA could send a transaction to a 3074 invoker and then have them actually utilize the benefits of 3074. And we've done some research and we think that it's going to be okay to allow for this. And we've also have some auditing firms looking into this to determine. So I wanted to add this as another motivation because I think it is a really important aspect of 3074 and it will bring a lot of benefits to users. So everyone, I think here knows what a sponsored transaction is. Account that pays for gas is not the account that is going to perform the action. And today, sponsored transactions exist, but they're mostly emulated with meta transactions. So Infura transactions and OpenGSN are pretty well-known groups working in the space. The issue that I think that's really stopping this technology from going mainstream is that there's not really a good way to interact with contracts that don't support meta transactions, and if there's no way to interact with that contract, then you have to redeploy the contracts you want to interact with to have this functionality. And the nice thing about 3074 is it allows you to kind of sidestep that and just interact with everything that already exists on mainnet. So another thing that we've looked into since we last talked was we did a Dune analytics dashboard, and I can send you the link if anyone is interested. But I was curious to see how much people are spending on ERC20 approvals. And I found that over the last month, users are spending $23.8 million just approving their tokens, just approving use of their tokens on Ethereum. And I'm pretty confident that in the worst case, we can improve this by about 30%. So every month we'll save users several $million. And I think that this is a pretty important thing to understand because this is money that users are actually spending directly out of their pocket to interact with the chain. And if we can significantly reduce that, that's a huge win for people joining Ethereum and not being so scared away about how expensive it is. So this is where we're going to go into more technical details about 3074, but I'm mostly going to skip over this stuff. So we're going to add two new opcodes, AUTH and AUTHCALL. AUTH is going to be the opcode that actually recovers the address from a signature, and AUTHCALL is very similar to the call opcodes, except it will set the message.sender equal to the address that was recovered from AUTH. So we have these contracts that are called invokers, and these are the contracts that sort of act as wallet extensions for accounts, and they are the contracts that actually do the signature recovery. And so the invoker is a very special contract in the 3070 world because it enforces all of the things that the protocol typically enforces that keep accounts safe. And so if you think about what you need to do to interact with Ethereum, you have to adhere to these replay protection rules. You have to have your nonce correct. You need to provide some amount of gas, and these things are deducted and incremented in your account. And the invoker is sort of the smart contract version of that logic. And so it's really, really important that these contracts are implemented correctly. The way that we have done the invoker is we have users signing over a commit, and this commit is the hash of all of the things that you would expect to be in a transaction. And these are the things that should keep your transaction secure from being replayed or from generally being manipulated. And so it might look something like this. You might have a commit that you sign over that is of the hash of the nonce to the gas and the call data. But the nice thing about the commit is that because it is just a hash of data, and the invoker smart contracts are able to verify and create any kind of commit message, you can have more complicated schemes. So a really nice thing about EIP-3074 is that it allows for users to basically batch transactions. And the ERC20 example is the ERC20 approve example is a good example, because typically if you want to approve and then do an action with that token, it must be done in multiple transactions, because you have to have the message.sender for your approve to be the EOA. And this actually allows the message.sender to be set arbitrarily. So you can call, have multiple, what would typically be transactions done within a single transaction. And so this leads to tons of benefits, from UX to saving gas, since you don't have to pay the intrinsic gas for each of these calls. Some of the use cases we talked about, but generally sponsored transactions, batching. There's ideas of having parallel nonces, transactions that expire, alarm clock style transactions, and generally just having contract wallets for free. This is like a really open design space, and I'm pretty curious to see what some of the people who are really working more closely with wallets and user experience can come up with here. So the caveats of 3074 are really important. Signing a 3074 message is going to give full control of your EOA to that invoker. And this is something that generally sounds scary, but you should think of it in terms of, it's very similar in terms of using a smart contract wallet. And if you're okay with trusting a smart contract wallet, there's really no reason to not also trust a 3074 message or a 3074 invoker. And I think that over time, as we develop some of these invokers, it's going to be that wallets are going to determine which invokers are trusted. And so you can sort of think of it as, if you trust your wallet, you trust it to secure your private key, you trust it to not do anything nefarious, so you also trust it to interact with 3074 invokers. And I think this is like a very reasonable approach, but I'm like curious to hear what more people think, because I'd say this is one of the most hotly debated topics around 3074 is like, is this an okay assumption to make? The other caveat that exists 3074 is the value has to be deducted from the invoker. And the reasons for this are, there is an invariant in the protocol that basically says you can verify a transaction is valid by just looking at the current state and the transaction object. There's no execution needed. And if you were to deduct value from a user during the execution of a smart contract, what could happen is that I could create a transaction which deducts all of the balance from an account who has 1,000 pending transactions. And so all of those 1,000 pending transactions would immediately become invalid. We think that there might be some ways to get around this, but for now, the most reasonable approach is to deduct it from the invoker and do further research on how to improve that. There's some other things around just the nuance that exists with 3074. I think that this this bullet point is from the last call, whenever we did not allow the self-sponsorship, which would mean that if the transaction origin is trying to become the authorized address, that was not going to be allowed. And this is something that we may still have to walk back. We may not allow self-sponsoring. In that case, it becomes, again, difficult to try and communicate to users how exactly 3074 works. And so I'm going to have to rely heavily on, the input from wall teams to understand how they think that can be done. And, generally, if we can't deduct value from the user and the invoker has to hold ether for the user, this is something that it's unclear how to properly educate users about. Users are very familiar with ERC20 tokens. They understand that they don't look at their account balance in their accounts in the try. They look at it under the ERC20 token. And this is kind of an extension of that, but it requires education and a good user experience. So the last slide here, I think, is just a couple updates. I mentioned that we had lifted the self-sponsoring restriction. So I think that this is going to be, if we get good feedback from these audits that we've started, I think that this is really going to help EIP-3074 be much closer to the best possible upgrade that we can have. So we have begun some audits with two firms. One audit team is looking at how EIP-3074 is going to affect contracts on mainnet. I think that some contracts today are using a really naive flash loan protection, which is just checking that the message.sender is equal to the tx.origin. And they do this just so that they are a little bit more secure against flash loans. And this EIP was going to break that invariant. And so it's important to understand how that's going to affect mainnet contracts. So we have a firm working on that. And then we also are going to have a firm who is going to audit the actual 3474 spec to understand if there's going to be any security concerns pop up that we haven't discussed. And they're also going to just do, a more thorough write-up on how those security concerns relate to what exists today. We've been working to release a testnet so that people can actually start building and playing around with 3074. And so I've got this link here to the Pushy testnet, which is we're planning to keep it running until there is confidence 3074 is going to go into mainnet and we can actually get it on Rinkeby and Ropsten. So all the information is in that link, and you can see exactly how to connect and deploy contracts there. We've had some discussions in all the all-core devs for the last few weeks, and it's pretty confident to say that we're not going to make it into London. The client teams really want to keep the London hard fork skinny and focus just on EIP-1559, but they are optimistic that a feature fork is possible quickly after, and we're considered for inclusion for that feature fork. That would earliest would be around October. If the merge happens around that time and they need to push back, the latest that might happen is February. So assuming that everything goes well with the audit, I am optimistic that we can, get this EIP into this hard fork, but it's still unofficial at the moment. It's something that we're still working for, but we are being considered for inclusion for it. We talked with Open Zeppelin, and they're interested in writing invokers, so I think that this is generally a positive sign. And if anyone else here is interested in writing invokers and working with us, we're happy to have some calls and discuss how to do that. And finally, we're working on some governance proposals with some DeFi projects to help fund EIP-3074 development, especially these contract audits, because like I said, the invokers are very, very important. They're secure. And so we want to make sure that the audits are done, done very thoroughly. We may even do some formal analysis if we feel that it's needed. And so these things are very expensive, and we want to try and fund that. So if you have any connections with DeFi protocols that would be interested in working with us on that, that would be good. Feel free to reach out to me offline. So I have questions, but I think we might just wait for a second because Onscar also has a demo that he wanted to show us. Is that right?
Yes. So because I think that might be interesting to people to just kind of see the EIP in practice for just like a minute or two. So let me maybe share my screen. Give me a second. Let's see if this works. So basically this came out of last week we wanted to kind of benchmark a little bit these kind of gas savings around batching transactions, and in that process we figured that like even better than just us kind of testing these specific use cases would be just like to enable people to just do it on their own, right? Like for whatever use case they're interested in, just be able to go ahead and create simple examples and actually kind of like run it, test it, measure gas costs, all of this. And so can you see my screen?
Yep.
Awesome. And so basically what we did was we forked Remix. So I assume most people here are like familiar with Remix. It's like a really nice minimal kind of JavaScript IDE for quick prototyping. You wouldn't normally develop your like production projects in there, but like for prototyping, it's awesome. So we deployed a fork. You can find it at remix.pushy.quilt.link. And by the way, like apologies if the pronunciation is badly off, but like as we are targeting the Shanghai fork, Pushy is, I think, according to Wikipedia, like the old center of Shanghai, so that's why we went with it. But yeah, so if you go to remix.pushy.quilt.link, you'll kind of arrive at this custom 3074 Remix instance. And for now, at least, if you're familiar with how kind of Remix works, you can either use a JavaScript VM or just like a local node. We haven't yet implemented 3074 in the JavaScript VM, so you have to connect like a node that is connected to the testnet or like to a local instance of the testnet or something. So you have to kind of actually go to Quilt, and then in the Pushy, as Matt was saying, you can find kind of like instructions to actually connect to the testnet. And once you're connected to the testnet, you can go here to remix.pushy.quilt.link. You can connect to your local node. So in my case, it's listening right now RPC on 8545. So here we are connected. You can see I'm connected to my rich account on our Pushy testnet. And by the way, if you need Ether for the testnet or something, just ping any of us and we'll gladly send you whatever you need. And so now we are connected. And the nice thing here is if you look at the compilers, we have a special EIP-3074 compiler. That is, we actually kind of forked. We forked Solidity as well, and we have a EIP-3074 branch. And if you want to locally kind of like use the compiler as well, you could just compile that. But like instead, you can just use this integrated compiler, which is easier. And that what it does is we didn't want to make any decisions on how, of course, Solidity would kind of implement it. So all we did was we only implemented it in Yule. So if you're familiar with how to kind of how to use kind of assembly within contracts. So sorry, I'm jumping a little bit, but I hope it all kind of makes sense. So we have like some example files here, and so right now the only way to kind of access 3074 functionality is in these assembly blocks, and the way you do it is kind of like with these in this way. And so like if we actually go we actually go to the EIP, then you can have a look and see like what the actual arguments are, right? So for auth you have like 4 arguments, and then for AUTHCALL you have like these 8 arguments, and so basically you just kind of like use them here, and then it does whatever it does under the hood. And so this is the way you can kind of right now write like example contracts. And so this is kind of like the minimal example. Is like a minimal invoker. This would not be useful like input on actual use on mainnet, because it's completely kind of like it makes all the kind of the mistakes security wise that you're supposed not to do, right? So for example, it just doesn't use a commit. It just uses like an empty commit thing, because anyone can just basically send any signature to it. So if I'm sending a signature, someone else could grab it and reuse it and so on. So this should not be used. This is really just for kind of like for having like a minimal version you can deploy and just play around with. And so we are just going to do this for now, just to kind of like get a feeling for how you could do it. So what you would do is you just create like a normal file. For now, I'm just going to use this kind of minimal invoker, and then also the hello world, and what hello world does. Where here we are. Hello world is just like a minimal contract that has like a public owner variable, and anyone can just become owner by just calling into it. And so now we kind of want to basically set the owner to an account that sent like a 3074 transaction. This is kind of like, this is our goal for this little experiment. So let's compile this with the special kind of compiler. And as you can see, this was successful. I mean, you could just actually write code in here. Of course, I'm only importing to use the kind of the thingies, but you can actually just write the content in here. And now we can just go ahead and deploy. As you can see, we have like these two contracts. So we are deploying an instance of Hello World, and we are deploying an instance of Minimal Invoker. And while this is kind of ongoing, I can also show you kind of like for creating these signatures, we also developed like a minimal plugin, and you can find that on here. It's in this list, EIP-3074 signers. You just activate that, and then you have this very bare bones plugin that lets you create these signatures that you need to use. So in our case, so we have kind of the Hello World deployed. For now, the owner is unset. But if I were to just transact directly, then in a couple of seconds, kind of this account, of course, would become the owner, but that's the boring direct interaction. We want to go through the minimal invoker now, of course. So like right for now, the owner is just F5. That's kind of like this address. But now we want to actually kind of set it to like a fancy kind of address of one of these accounts of this account. So like this tab has its own kind of, for now it only has this one option. So it has its own kind of internal JavaScript wallet that's kind of has this address 5075 whatever. And that is kind of like only used to sign these messages. In the future, we also want to add like functionality to sign with the get kind of like exposed key as well. But for now, it's basically just an internal JavaScript wallet to keep it separated. So what you would do is you kind of and by the way, if all of this is too quick, by the way, we're recording this, so feel free to kind of go back and kind of rewatch this if you want to run through the steps yourself. But basically, what we now need to enable to create a 3074 signature. So if we go to the EIP for like a signature, the signature has to be signed over kind of like this. So like the commit, the invoker address, and this magic kind of prefix, the 0x03. And so we kind of have to give it an invoker address and a commit to actually kind of to create the signature. And again, for like minimal invoker, the commit that it expects is like empty. So we can just leave that empty, but we need to give it the invoker address. So in this case, we give it the invoker address. We can just leave the commit empty. We can just create a signature. It's all, again, that very bare bones for now. So you have to kind of like switch back and forth a little bit. It's kind of annoying, but I hope it's not too bad. And of course, feel free to write your own kind of help us or whatever if you want to. So basically now I copied over the, and what was the Y parities one. So this is kind of the signature. This now, again, this is terrible design because now this authorizes kind of the invoker to send any arbitrary transactions from this address, from 5075. But again, it's just for like demonstrating to you that this works. So I just copy the address for this hello world, and I'll send like a transaction without any data. And this should kind of like now, again, for now, the owner is still this our normal account, F5, whatever, but it should become the other account, 5075, as soon as this goes through. So let's see. Here we go, transaction is mined, and it is indeed now the owner is this 5075. So kind of the transaction actually came, of course, from this invoker that usually would set message.sender to this address, but instead it actually was set to this address, right? So this is exactly kind of what auth calls are supposed to do. So this is kind of like a nice, just like a hello world example. And just like as a little quick aside, so what we also kind of did was we implemented support for 3074 in the debugger. So if you want to kind of actually go ahead and look at what happened in detail, you can kind of open the debugger, and then you can actually step through execution. So let me kind of scroll through the interesting bit. I'm not. Oh yeah, here we. Yeah, I'm a little bit surprised just because usually it kind of automatically jumps to the beginning of the doesn't really matter. So I just have to find where it. Yeah, it's maybe a little bit. Okay, so here we are. So as you can see, basically, for example, here we have the auth call. You can see how much gas it consumes. All of this. If you step one further, you are like now inside of this contract. All of these variables kind of like are correct. So basically, all of this works as you would expect. And so now you could basically with this now you could also kind of create actual kind of more functional invokers. We only just now started kind of to fill this example contract repo. So over the next few days, there will be like more and more kind of interesting invokers. So for now, for example, I created just now, like literally 27 minutes ago, like a trusted batching invoker. So trusted in the sense that basically it also doesn't have replay protection. So kind of like the person sending and the person signing have to trust each other. So there could be like two addresses from the same wallet, for example. And that kind of like that basically takes in multiple calls and batches them. And well, maybe I can just very quickly. So let me just give you like a very quick example. Show this very quickly. Stop me if this is just like terribly boring. That's fine as well. But I think it's kind of like a nice little thingy. So this time I'll deploy 2 Hello World contracts and a trusted batching invoker. And the trusted batching invoker will kind of like claim ownership of both of them in one transaction. And this, of course, would not be possible. Oh yeah, okay, this is still pending. This, of course, would not be possible calling from EUAs directly, right? Because this is kind of like if you were to call into both of them from this EUA directly, then you'd have to send 2 transactions. But now we are sending 1 transaction into both of them. I don't know. Maybe it's actually. Yeah, I don't know. It's maybe a little bit. Maybe I'll just continue clicking a couple buttons here, and maybe if people already want to go ahead and like ask questions or something and start the conversation, then maybe now is a good time because that'll take me like probably a minute or so just to fill out all of these kind of fields and click buttons. But I'll continue sharing my screen, so just for like closure and for kind of this aha moment where it actually works. But feel free to kind of like start the conversation.
Thanks, Onscar. Does anybody have any questions or comments or discussion items?
I think Micah asked earlier in the chat for the code for the 30% reduction in authorize and transfer. Is that something we have available, or?
Yeah, good.
Oh, no, I just wanted to say that this was basically like a project that like once we have this set up and running, and again, this kind of like it's just done today. Now, actually, kind of like the next steps for us would be to actually measure specific use cases. So even just with this batching invoker, I mean, this is of course not optimized for specific use cases. You can always be more gas efficient for like if you create an invoker that is specific to the authorize and transfer use case, right? But even with this. I think kind of like the 30% number came from just running this on like just like a Open Zeppelin implementation of a token contract. I think that came out at something like this. But basically the exact numbers, we would kind of like want to play around a little bit with optimized versions of that. And once we have kind of like a specific final invoker design then we would kind of publish a specific kind of benchmark with a more specific number than 30%.
Yeah, I really roughly tried to sketch out what that would look like in assembly, and I estimated based on that. But it's definitely not exact, and there's possibility for an error, but I'm pretty confident that it's going to be at least 25% or 30%. I think the numbers I got from this actually showed it was closer to 35%, but I assume that there will be a little bit more additional costs. Does anybody have anything to share about things they've thought about using 3074 for? or any updates on anybody's end since we talked about a month ago?
I think I just had a question for from our last conversation. It seemed like an open-ended question still regarding like getting the gas estimations, and I wasn't sure if that had already been resolved or is like a lot more straightforward now, or what. Just from like a wallet's perspective when interacting with 3074 and being able to show to users like for certain transactions like that are bundled up, like what would be the estimated gas in advance of doing the transaction.
Do you know the latest on this, Sam?
No, sorry.
Yeah, so I think, right, like the last we discussed, I think there are several different design choices for kind of inner core gas estimation. One that we came up with was kind of like so basically the question is you can have a very clean version that would need some Geth modification. So Geth would have to have new interfaces for these estimations of the inner core cost, where it kind of like keeps the outer constant and then varies the gas for the inner calls to kind of test how much gas is kind of sufficient. An alternative to where you could basically leave Geth as is, and for that reason would be my favorite, is what you could just do is you can just basically have an alternative code path in your invoker that basically at the end of the day, that at the end always reverts, but it basically executes and then kind of like returns the actual gas consumed. And so then you could basically just send the transaction through that code path, and then like in the revert message, you could pass out the kind of the actual gas consumption, and then you could basically use that within like an auth call to get out the gas you have to pass in or something. So I think it's basically like an open design space, but I think there are like good possible solutions to do that.
Okay, cool. Thank you. Yeah, because I recall that there was a little bit of like circular confusion in terms of being able to pass in estimates into the payload that would be like hashed in versus not. So I guess that's all fine.
Yeah. So basically, I think what you can't do is you can't basically just use the normal gas estimation, because that would kind of conflate the inner gas and the outer gas. So you actually have to do something special for gas estimation. That part I think we can realize. And then as you were saying, you can't just use the normal code path, because usually kind of the gas to pass into the call would be one of the fields that you authorize, that you authenticate with the commit hash.
Right.
So either basically you have to have a special Geth mode that kind of like where you basically just kind of skip this authorization step only for gas estimation, or you again have this alternative code path where you wouldn't authenticate the gas, but so that way you'd be flexible.
Cool. Thank you.
Also, I'm going to stop screen sharing now, but like if maybe any of you saw, like indeed kind of like we actually ended up having one transaction that set both of these values in different contracts. So the batching works. Yay.
Cool.
So I have a question around use cases, and apologies, I joined the call late, so apologies if this has already been covered. But one of the statements I've seen regards this EIP on social media, on Reddit a lot, is that there's an assumed use case, which is with this EIP in place, there is a use case where token holders will be able to transfer their ERC tokens without having any ETH balance in their wallet. Is that the case?
That is the case.
Excellent. And sorry, go ahead.
I was just going to share like one other idea that had occurred to me over the last since the last one. There's always like the debate between like EOAs and contract accounts or whatever. This does also provide like a path to like kind of upgrading accounts. Like a seed phrase based account could literally like sign a single delegation message to a contract account, and then you could just throw away your key. Like, okay, so you know, it's only as safe as like having truly disposed of it, but you could, you know, wipe it from your local device and basically, you know, gain a lot of the security benefits of having like a multi-sig or something like that.
Yeah, you can actually do it with a like a constructed signature as well. If you want to create a multi-sig that looks like an EOA.
Sorry, could you say that part again?
Sure, you can use like a constructed signature where you choose the VRNS instead of having a private key, so there is no private key for the account, and then you can use that as a multi-sig if you want, or
yeah.
it looks like an EOA.
Sure. So I'm like highlighting that you could open the entire design space of contract accounts. So you could take any authorization mechanism that's used by, you know, you could turn your account into, you know, being controlled by a token weighted democracy, or, you know, whatever you prefer.
Yeah, that's a good point.
And this is also why we kind of really want to add this functionality of sending, like taking Ether out of the signing account in the future, right? Because in the first iteration, the one thing that basically you would run into if you throw away the private key is that any Ether that ever gets sent to this address, maybe even just by mistake, would be lost forever, right? Because there's, for now at least, you would need to actually send a transaction from that account to get the Ether out again. But in the future, hopefully, AUTHCALL will also be able to take the Ether out of the account.
Cool. Yeah, good to keep in mind.
Yeah, I just want to make a quick comment for Sean's point. Sorry, Sean, do you want to go first? As I seen you on mute.
Oh, no worries.
So basically, you know, Sean's point was, you know, can we use, will this allow us to do the approval and send a transfer using ERC20 tokens? I think there's still a caveat with that needs to be highlighted, is that someone else is sponsoring the transaction for you. So there's still a sponsor. So you're giving the transaction to, let's say, ITX in this case, or I think Economy's on the call, so you can also say Economy, and they'll pay the ETH in your behalf. But of course, you'll get your approval and you'll reward the sponsor in ERC20 tokens. So it just makes that like frictionless, as right now there's a huge amount of friction and makes it really impractical to do at the moment.
Thank you. Nice one. And then the second question I had was there's been some sort of feedback on Reddit and Twitter just around how long this piece of work has taken to come to fruition, on the assumption that it's almost there. Like it sounds like there's consensus around this going into the future fork after London, which I think is reassuring for those who've been pushing this. But are there any learnings that you might take just based on how long this particular piece of work has taken to get through? Or is it just, this is how long it's taken and that's that? Any thoughts there?
So I will say that we aren't, you know, officially included in the Shanghai fork, so it wouldn't be correct to say there is full consensus on that. Sure. I think, yeah, we're optimistic for it to happen, but we still need to get client teams to say, like, yes, this is definitely going to happen. But yeah, you know, it is something that's taken a really long time. You kind of look through the history of improvements to the UX of accounts. There have been a lot of proposals, and I think, you know, the very first proposal was kind of this idea of account abstraction, which I feel like 3074 learned a lot from. And that was proposed back in as early as 2015. And through the years, there have been many different proposals. And I think like the learning is that, number one, it just takes a really, really long time to change the Ethereum protocol, which is generally a good thing for such a large decentralized system. But the other thing is, I think that, you know, it just hasn't been the number one priority of the community and the people working on the protocol to actually resolve this, because it generally works good enough. And there were these ideas for a long time that meta transactions were going to be the savior. And I think that they just didn't really materialize to fully resolve the issue. And so I think that thinking that there was a savior kind of led people to maybe not spend as much time on trying to improve the core protocol. And now that it's becoming more apparent that meta transactions probably aren't going to fix everything, that there should be efforts to actually resolve this in the protocol, that sort of push people to look more into it. And I think the thing that really kicked off this latest iteration on these types of EIPs was some discussions that happened last summer, and it turned out that more like higher level core changes to the protocol, like fundamental changes to how Ethereum works, kind of led us to metatransactions as a very special type of execution on Ethereum, and that execution was potentially going to be broken by upgrades that were being proposed. And so that led a lot more people to look into, and I know that Micah wrote EIP-3074 as a response to kind of, I think, some of those things. And that sort of led us to working on, I wrote an EIP-2733, and then Sam wrote 3074, and that led us to like really focus a lot more on it. So like, you know, TLDR is that it takes a long time, and people are generally just focused on making Ethereum keep working forever rather than trying to improve UX. But I think improving UX is really important, and I'm glad that there's a lot of mindshare going behind it right now.
Yeah, I could also add a comment to that, like just to the meta transaction part. So obviously it was mentioned that, you know, meta transactions may solve this problem, but I think the bigger issue is that meta transactions don't work very well without the CIP. You know, it's sort of like the EVM wasn't designed. So if you look at an Ethereum transaction, it combines who's going to execute the transaction and who's going to pay for it. That separation was not really considered, I guess, when the EVM was designed. You know, we sort of get it with wallet contracts, but we don't get it for EOAs. And so now it's just clearly creating that separation to allow meta transactions to actually work properly.
Yeah, that's a good point. And we had some pretty interesting conversations with the OpenGSN folks. And I think that kind of led me to a better understanding of how some of these pieces fit together long term. And one of those, the idea there is basically, you know, for a long time, account abstraction was thought of this holy grail as going to resolve all of these UX challenges. And we spent a lot of time last year working on account abstraction, thinking through like what's possible with it. And that, you know, sort of led us to kind of a bit of a dead end for the near term, because it is a pretty large change and changes some things about the protocol. And it's hard to like push through right now with all, you know, 1559, the merge, all of these things happening. And so, you know, 3074 is kind of seems like the smaller thing, but provides a lot of the benefits of account abstraction, but it's not kind of account abstraction. And so the way that like I'm kind of thinking about it now is that 3074 is really this drop-in replacement for meta transactions. It's like the proper meta transaction. It's the protocol accepted version of meta transactions. And account abstraction is sort of a replacement for the infrastructure layer around meta transactions, because account abstraction lets a contract pay for the execution of a transaction. And so it might be possible to replace inferior transactions or Myconomy or OpenGSN fully with account abstraction. And so this is something that's maybe like a further step forward to remove the middleman from interacting with the Ethereum network. And it's like a really complicated problem, because what inferior transaction and these relayers do is a really non-trivial task, and trying to put that burden onto all consensus nodes is potentially like a very big ask, and maybe it's more likely that we're going to get a very watered down version of what these relayers provide. But that's kind of how I see the transition, like the differences between 3074 and account abstraction. They are very complementary to each other. And account abstraction sort of unlocks more potential around it.
So we have shared about this meeting on the Reddit. So one of the questions that is coming up from the Redditor, generally he mentions that this is rare, but he wonders what can be done to mitigate a malicious invoker. I believe this is a generalized question that has been asked again and again. So is it realistic to expect the community to spontaneously rally around a couple of trusted implementation?
I think that's really the only thing we can expect. People, like, you can't stop people from aping into untrusted contracts, but generally speaking, I think the majority of users and the majority of wallets have to agree on a small set, or a relatively small set, of invokers that everybody can trust.
You know, unlike aping into random contracts, your wallet needs to explicitly support the invoker, unless you're aping into it with custom tools, in which case, well, you're on your own.
Yeah, exactly.
I'm not sure if Dan wants to expand on that a little bit, because I know that he's written several things about this.
Yeah. I mean, that's basically it. You know, these signatures have a prefix that right now wallets don't sign. At least no wallet signs it without a warning that says this could give over control of your entire account. If this were live, you know, we might increase. So today MetaMask does allow signing arbitrary hashes, and we have a grave warning about, you know, this can compromise your account. We might add more friction to that signature. In the context of this, we might actually disallow signing things with the 3074 prefix. You know, there's a lot of options for how to do this securely. The safest thing a wallet can do is basically don't sign you know, data that you don't understand as a signer, and especially if it has this small prefix at the beginning, then just don't sign it. And as long as you're not signing arbitrary data without you know, scary warnings, then you should be fine. And then down the road, we can start exploring things like, well, if some wallets want to let users or developers do really risky stuff, you know, we're in the Ethereum community, we've got a lot of hackers, a lot of people get really frustrated if you don't let them have a way of doing stuff. And so I do think that in those cases, just providing enough friction, enough forced education and consent is kind of like the path to enabling that kind of thing also.
This is a dumb question, but if I wanted to fork MetaMask, am I fully able to fork it and change MetaMask and have people install it in Chrome?
Yeah, so for personal, nonprofit, and distributions of fewer than 10,000 users right now, yeah, so you can fork it, you can add your own invoker to it, and it's very possible that, you know, given the context of this, we might allow a mechanism for developers to add and develop invokers, because we're going to need some environment to do that. Like if this becomes available, it's going to be really awkward for invoker programmers to write them without the context of having any wallet that can support them.
Yeah. One thing that I thought about pretty recently is that, you know, today there's not so much of a desire to run a custom version of MetaMask as far as like I'm aware, because MetaMask already does about everything that you want it to do. But I worry about a world where with 3074, because that may increase the desire for users to run forks. And I don't think it's good for users to run a fork of MetaMask. I think that your team does a ton of work to keep MetaMask secure, and having people run custom forks where they're not updating it and potentially doing malicious things is really bad. So I don't know if you have any thoughts on this, because I see this world where, you know, users who really don't understand what they're doing, they read a Medium post that says, download this version of MetaMask. It lets you do these amazing things in ape land. And they are like, of course, like I want to ape like everyone else. So I'm going to download Metamask Lite. And I think that to me is like one of the most concerning security areas. And I don't know if you have any thoughts around that.
Well, I think that our solution to that is very similar to a couple of the other big ecosystem innovation problems, like adding new blockchains and adding contract accounts, which is, you know, we've got work on an extensibility system that we're calling snaps. And it's totally feasible that we could write an API surface for basically adding a script to the wallet that lets people add invokers. We're not sure what that API surface would look like yet, because it's very likely invokers would involve like some amount of custom UI. I don't know if it would be inserted on the confirmation, or it might be additional confirmations. But we're going to be having a more prominent and like easily contributable beta program for that. So we should be able to have that conversation you know, soon.
That's cool. Yeah, I think you make a good point too about like what will the interface between the wallet and, you know, I assume like these Web3 sort of frameworks to interact with invokers. How do you think that we should develop those standards going forward? Like, is that something that you think is going to be an ERC that people are going to discuss, and we're going to work together with, you know, Ethers and Web3 JS and figure out like how can we, like, is it going to be more of an arbitrary interface that can support many types of invokers, or do you think it's going to be, you know, still more custom built around certain things?
I'm not completely sure. I assume at the beginning we'll at least try out, like, we're going to have some really low-hanging invokers that I think a lot of wallets will probably just rush to integrate, like batching is just like, oh, we can save gas. great, a proven call, that might just be an easy one. And wallets may just hard code that. It's a much longer question about like what's the interface for extending the types of signatures to the wallet. So yeah, I think it has to be an open conversation, and I bet there's gonna be a lot of ideas on it. And there will probably be, a version of it that we didn't account for some use case, and so we have to add to it later. So, that's kind of how this stuff goes.
For the low-hanging fruit, do you think that that's something that is going to have to be supported by dapps, or do you think it's something that MetaMask is going to be able to be smart enough to say they just called to send transactions? Like, let me ask the user if they wanted to batch that.
So, I mean, if you just call to send transactions today, like we might, the user might approve it before you send the second one. So there'd be a trick to the user like not replying in time. There is a provider method for batch transaction. So wallets could overload that and then pass it through this. So I do think there are ways that parts of this could be abstracted away. Plus, if you had like meta transaction support at the wallet layer, you could totally have, the dApp doesn't need to know about how you're paying for the transaction or how you're submitting it to the chain. So it's totally possible a wallet and a user could have their own preference for the currency they're paying for a transaction. And yeah, like we said, we're separating the concern of the transaction payment and the authorized execution.
Yeah, that's cool. Thanks.
There's scenarios where like the dApp needs to be somehow aware of it. For example, like just one normal use case, any DEX, right? Where you have like a first approve scenario and then you have a swap scenario, right? Usually like the UI on those apps, they disable the swap until you get the approve, right? And then in the case of having both, like the app will not take advantage of it, but with the current design without making any change, right? So we gotta think about that too.
Yeah, and there's a nice proposal for listening to transaction if they get sped up or something or retried, but we probably need a step even further than that, where we're not tracking transaction hashes anymore. Like dApps in that world, they'd need to be tracking like the intent of the transaction. You're almost like watching for an internal message, not for a transaction hash anymore. So yeah, that's a good argument for making it a new method and not just overloading the old ones, because you could break existing dApps if you just started doing that.
What do you guys? Oh, sorry. If I could just ask one other thing. What do the wallet teams think is a good lead time for having low-hanging fruit support? Because this is something that we're trying to understand as we're working with teams to develop invokers and figuring out when is a hard fork possible. Is this something that teams need 3 months, 6 months? Can't answer right now.
On our end, it is hard to answer. Like between 3 and 6 months. And I think that's part of why I'm kind of the camp of like, if we miss London, but we get October, like that's not the worst, because we've got this test network. So we're kind of already unblocked to build when we're ready to. And we're kind of going to need wallet support to really build for this.
So the one other question that I was about to ask, that was also based on the timeline itself. Considering that this audit is going to be an important consideration for most of the clients, I'm talking in reference to the last all code dev meeting. It seems like client devs are more inclined towards having this included based on the report. So do we have any estimate on the timeline of the audit report? When can we expect that?
Yeah, the audits we expect to be done between mid and the end of May. So I would say we would have pretty good answers by then to how that's going to interact with the Ethereum network. And I think it's like important for like everybody involved to have actually decide that it's going to go into a hard fork as far out as we can, because that's going to give everybody the time to develop the tools that interact with it and to actually test and verify that everything's working correctly. So hopefully, like if this is going to happen, we should know sometime in early to mid-June.
That's good to know. And now it seems okay as well. Like even if we did not get into London, the chances are high to get into Shanghai with that.
Yeah, I think as Matt was saying that it's of course always, I mean, the governance process takes some time to kind of like fully figure out which EIPs are accepted for which fork, but at least the main kind of the main reason even behind having the feature fork in the first place was the 3074. So like the reason why all code devs decided to try and fit in like another feature fork before the merge was specifically because people really kind of wanted to have 3074 as fast as possible. So it's really more like barring any major problems coming from the audit, likely it will move ahead, I think. Although of course, I mean, these things you can never say for sure. Yeah. Also, like I just now created a Telegram group because, as Matt was saying, my Telegram might just work out better than the Discord one, and put the link in the chat. So anyone who wants to kind of follow along with 3074 developments between these calls, feel free to just click the link and join the Telegram group.
Yeah, thanks for making that, Onscar. Looks like we're kind of closing out on the end of the call. Does anyone have any last questions or comments?
Well, this is great. I hope the presentation and the discussion may have helped to clarify many doubts, but if we could not include some of the questions, I'm going to provide the link. Ansgar, would it be okay to add this Telegram link in the description for people to join in, or?
I think so.
Yeah, I think this one specifically might be like a temporary one. I'll just message you with like a permanent one, if that makes sense.
Yeah, definitely.
Okay.
So with the explosion of tokens, those are built on the Ethereum network, it becomes common for Ether to hold valuable assets. And we were talking about it, like how sponsored transaction break the circular dependency without Ether to pay for the conversion. I'm assuming this EIP-3074 is going to be a revolution, at least in the for the dApp developers here. So on behalf of the Ethereum cat herders, I would like to thank all the co-authors to bring the community up to the speed with the development work and the testnet. The demo provided by Ansgar is there in the recording, so people can go back and refer to. Also extending my gratitude to all the participants of this call for taking out time and joining to share your viewpoints on this proposal. Looking forward to seeing this implementation on the major clients, if and when approved by the client desk. Best wishes for that. Thank you all for joining us today.
Thanks a lot, Pooja. Thanks everybody for coming.
Thanks all.
Thank you. Bye.
Thanks all.